In today's world of advanced technology, running large language models locally on powerful GPUs often feels like summoning a jet engine at your desk. The relentless fan noise as your GPU hits full throttle is all too familiar for those pushing the limits of hardware like the RTX 5090. But there's good news. You don't need custom water cooling to manage this inferno. Enter undervolting and power limiting, two software-driven strategies that can keep your system cool, quiet, and efficient without breaking the bank or taking unnecessary risks. Unlike gaming, where GPU performance is tied closely to clock speed, local AI inference largely hinges on memory bandwidth. This means you're often not maximizing your hardware's potential by running it at maximum voltage. Undervolting involves finding the lowest stable voltage for your GPU, effectively reducing its power draw and heat output without significantly affecting performance. Meanwhile, setting a power limit caps the amount of energy your card can consume, further easing thermal strain. These techniques can substantially cut down on GPU heat with minimal impact on processing speed. For those using the latest GPUs such as the RTX 5000 series, undervolting remains a top optimization choice. In practice, monitoring GPU health is crucial to prevent thermal throttling, a process where your card slows itself down to avoid overheating. By capping power draw, you not only reduce this risk, but also lower noise levels and extend your hardware's lifespan. In environments lacking advanced cooling solutions, like the typical basement lab, these methods are invaluable. A cooler GPU means less aggressive downclocking during intensive tasks, quieter fan operation, and a longer-lasting machine. If you're running local AI models, remember that VRAM is key. Undervolting ensures your chip uses power more efficiently without sacrificing this precious resource. Start by setting a power limit using your preferred utility software, often around 80% of the card's TDP, and observe any changes in performance. You'll likely notice little to no drop in speed, but significant improvements in temperature and noise levels. Ultimately, optimizing hardware is just as crucial as refining your models. By focusing on thermal efficiency rather than raw clock speeds, you can sustain a high-performance AI setup without turning your workspace into an oven. So next time you're pushing your GPU to its limits, consider giving undervolting and power limiting a try. It might just be the solution you've been looking for. If this helped, like the video and subscribe for more.